I want to show you my battery backup solar system. It was designed and built by me. It comprises 6 250 watt solar panels on an east facing roof and 4 250 watt panels on a west facing roof. There was no suitable north facing roof. Now I'll show you around the system and how it works. The east facing panels output comes down through that circuit breaker up there, down to this voltage and current measuring panel, and you'll note that it's showing 32.2 volts. That's because the panels are wired in parallel, not in series as in most commercial solar systems. From there the output comes down to this charging unit, and that regulates the charge going into the batteries, and from there it goes to the battery control box. On the other side, from the west facing panels, they come down there through this circuit breaker, again into a voltage and current measuring box, and then down to the battery control box. Now I'll show you the batteries. First of all, I'll remove the battery cover, which is a protective cover to stop particularly anything metal falling on the batteries, which could cause a fire. And on the top layer we have 4 120 ampere hour AGM type batteries. Being AGM, they are sealed and there's no fumes coming off. And as you can see, they're wired in parallel. And underneath we have another 4 wired in parallel, exactly the same. Then the 2 lots of batteries are wired in series to produce a 24 volt output to feed the inverter. But first it goes via this monitoring device here, which monitors the voltage of the batteries and prevents them falling below a certain level so that the battery life is prolonged. This is set to 12.1 volts. Below that the system will drop out and it will no longer power the inverter. At the moment it's reading 12.5, the red light's on, meaning this device is actuated, and when that's actuated it energises this 200 amp relay which feeds the inverter via a circuit breaker. Now the inverter is a 2500 watt pure sine wave inverter, but it does have a surge power rating of 5000 watts, and this allows for a high current drain on a fridge and freezer startup. From the inverter, the 250 volts now goes out to one side of this changeover switch, and on the other side is the grid, and the changeover switch ensures that there is never a connection between the grid and solar. It's a motor driven mechanical switch, and when it's actuated, one side closes one switch, and after a 1 second delay the switch on the other side is open. So under no circumstances can the solar system send voltage back into the grid. And I'll demonstrate the operation of this by turning the inverter off as if we had a power failure in the solar. And as you can see, it moved over, it's now being fed from the grid. I'll turn it back on and we'll go back to the solar again. See, there's a delay so that there's no way that there can be 2 switches open at the same time. From the output of the changeover switch, it goes to this panel here via a circuit breaker, and then through an RCD feeding all the household lights, and another RCD for power, and that provides power to a refrigerator, freezer, office with computer, printer and charging stations. You can see at the moment the solar system is producing on this device here 239 volts, and the circuits that it's feeding are drawing around about 355 watts. And that basically is the system. Now this system has 2 advantages. One, at night it'll continue to produce electricity, thus saving money, whereas your ordinary commercial grid connected solar systems shut down at night. And the other advantage, a big advantage, is in the event of a power failure, the commercial systems connected to the grid by law must shut down immediately and stay shut down until the grid is restored, which could be days, weeks, who knows. But under our system, we will continue to supply electricity to our essential services as long as we want. And there you have it.